So right, coming to the topic, limits. This is actually one of the topic in calculus.
I'm in Calgary.
Yeah. So it is one of the important topics in technical maths. So those who are preparing for engineering maths and those who want to do like research in engineering side, so this will be highly useful. So this part of calculus contains limits, continuity, differentiation, integration, all these things. And limits is one of
Yeah,
the
we're on continuity right now.
yeah. Yeah, sure. So, and limits is one of the important topic and the base topic for all these things. And even differentiation is also a byproduct of limits, I can say that. Yeah. Let me start with a simple example. Let me take let any polynomial or any function f of x is equal to some x square plus 3x plus 2. And if I ask you to find the value, if I ask you to find the value of f of x at x is equal to 2. So without any second thought, we will directly replace the value of x is equal to 2 in this equation.
Yeah.
So it would be,
You'll substitute, right?
yeah, 2 square plus 3 into 2 plus 2. 4 plus 6 plus 2, it will be 12, right?
Yeah.
Now the purpose of explaining this topic is, here we are finding the value of a particular function or a particular polynomial at a certain definite value. So we were given to find the value of that function at x is equal to 2, and when we are substituting the value of x is equal to 2 in the function, so the value which is coming is completely predictable. I mean, the outcome is predictable, so we can directly say the answer is 12 by calculating the answer. So there is no uncertainty in that. uh, what I can say, there is we can directly plot the graph for that. There is no uncertainty. It's not like undefined. It's not like we cannot find the value at that point. It's not like that. So for this type
Yeah.
of examples, there is no use, or I mean, there is no need to take the concept of limits. Now what a limit says is, for example, if a function is somewhat critical in sense of, what I can say, the value will change at a certain point. Let me show you with an example. Let f of x is equal to x square minus 1 by x minus 1. Let f of x is equal to x square minus 1 by x minus 1. And if I ask you to find the value of function at x is equal to 2, again I'll just replace the value of x is equal to 2 in the function. It would be 2 square minus 1 by 2 minus 1. So 4 minus 1, 3 by 1. So it would be 3. That's fine.
Yeah, but
Yeah,
if the denominator equals to 0, then you have to like
yes,
not
yes.
like
Yeah.
substitute, right? You have to like rationalize or factorize, right?
Yeah, we have certain different methods. We can do rationalization, we can do factorization, we
If
can
the
do
denominator is equal to 0.
exactly. But there is a little bit correction in that. If the denominator is not only 0, if we get some indeterminate forms, so I'll explain you in the meanwhile. Let me complete this topic. Yeah, even at x is equal to, say, 3, we'll get the definite value. So 3 square minus 1 by 3 minus 1, it would be 9 minus 1, 8 by 2, so it is 4. And even at x is equal to 1.5, let us say, so 1.5 square minus 1 by 1.5 minus 1, so it would be 2.25 minus 1 by 0.5, so it would be 1.25 by 0.5, somewhere it would be some 2.5. But
Okay.
when you check the value of that function at x is equal to 1, when you check the value of function at x is equal to 1, it would be 1 square minus 1 by 1 minus 1, which is completely 0 by 0. And we cannot say the 0 by 0 value as undefined, and we cannot say the value of 8 as 0, because we know that 0 by anything is 0, and anything by 0 is undefined.
Yeah.
But here the value is completely unpredictable. So we cannot see, it is neither 0 nor undefined. So if there is only denominator, if there is 0 in denominator, then it would be undefined. And if it is there 0 only in numerator, then the value will be 0. But here the value is what you call unpredictable, indeterminate form, so 0 by 0. And now how will you calculate the function value at this point is, so we have certain process called using limits, and here in this chapter we'll use all these types of topics. Okay.
Okay.
Yeah, so let me use the slide to explain all these things now.
Yeah.
Now at x is equal to 1, the function value is 1 square minus 1, sorry, it should be x minus 1. 1 square minus 1 by 1 minus 1, which is 0 by 0. And this kind of forms are known as indeterminate forms. They are neither a finite value nor undefined. We know what is the meaning of undefined. Undefined is something which is against which we can approximately say the value as infinite. So because the infinite is which is uncountable, even undefined is we cannot divide anything by zero, so we can directly say that which is against the laws of mathematics. Yeah, undefined is completely acceptable in mathematics, undefined is completely acceptable. But indeterminate, we can either say it as undefined, yeah, completely indeterminate, so we cannot find the value, or we cannot, so there is no particular what you call topic or debate in the in this kind of problems. Now there are some other forms which we can use these limits to avoid such kind of situations. So whenever the value is 0 by 0, or whenever the value is infinity by infinity, or whenever the value is infinity minus infinity, and whenever the value is 1 power infinity. So all these are very famous four kinds of indeterminate forms. One is 0 by 0, and one is infinity by infinity, and one is infinity minus infinity, and one is 1 power infinity. So whenever we encounter these problems, we have certain different methods. One is by doing rationalization, one is by using formula, one is by using by taking something as common or factorization. Then we can do the problem as in a regular way. Now let me explain you the topic or the main concept of limits, using limits for this kind of problems. Now at x is equal to 1, the value is not determined, so we cannot determine. Now with the help of our common sense, we can find the value of this function at x is equal to some 1.01. So it would be 1.01 square minus 1 by 1.01 minus 1. So let me calculate it here. 1.0, sorry, 0.01 square minus 1 0.021 divided by 1.01 minus 1, 0.01. Yeah, so complete the value is predictable, and the value is 2.01. Similarly, the value of function at 1.001, at 1.001, even that also we can find with the help of calculator. So it's also completely
2.001.
not exactly, because we are doing division, right? So let me calculate. Okay. 1.001 square minus 1 divided by 0.001, 0.001. Yeah, it would be approximately minus 0.99, something which is very near.
Yeah.
Yeah. Now at x is equal to 1.1, even that I think we can directly do this. At x is equal to 1.1, it would be 1.1 square minus 1 by 1.1 minus 1. It would be 1.21 minus 1 by 0.1. It would be 0.21 by 0.1, and the value is 21 by 10.
Okay.
21 by 10, I think so. Yeah. So it would be approximately 2.1. That means whenever we are approaching, see, at 1.001 the value is nearly 1 or something like that. Let me calculate once again, so I have some doubt in this value. 1.001 square minus 1 by 1.001 minus 1. So to make it fast, I'll do with the help of scientific calculator.
Yeah.
Yeah, it's what you said is approximately, yeah, exactly correct. 2.001. Now
Okay.
see, if you observe the pattern, yeah, the function value at x is equal to 1 is 0 by 0, which in turn is indeterminate form, and at x is equal to 1.1 it is 2.1, at x is equal to 1.01 it is 2.01, whereas at x is equal to 1.001 it is 2.001. And so these are the right hand side of 1, so we are increasing, we are increasing the values from 1 to the right side on the number line. If you imagine the number line, we are increasing the values from 1, because we got no value at 1, so at 1.1 the value is 2.1, and 1.01 the value is 2.01. At 1.001, that means when we are closing to, when we are going very close to 1, 1.1, 1.01, 1.001, when we are closing, when we are going very close to 1, the value of function is 2, right?
Yeah.
That means from this we we can conclude the value at x is equal to 1 is 2, but it's not exactly correct, right?
Yeah.
Even when we go on the left hand side of the number line, so when we calculate the value of at x is equal to some 0.999, so even that also we can use with the help of calculator. Let me do it. Yeah, it is 1.999. That means when the values are approaching 1, when the values are approaching 1, the function is 2, the function is very close to 2. See, at x is equal to 0.999 the function value is 1.999, and at x is equal to 1 it is indeterminate, and at x is equal to 1.1 it is 2.1, and when we are closing, when we are going very close like 1.01 it is 2.01, and when we are going very close again 1.001, so it is again 2.001. That means when we draw a number line 1, 0.999, 2.001, 2.01, 2.1. So when we are when we are going very close to 1, the function value is here, sorry, 1 point, yeah, the function value is very near to 2, the function value is very near to 2, but at 1 it is not determinate, at 1 it is not determinate, but when we are going very close to 1, that means these close values near to 1 are called neighborhoods of 1. On left hand side, when we go to left hand side, that means what you call, when we are decreasing the value from 1 like 0.999, 0.998, 0.997, like that, those are all called left hand neighbor limits of the 1, and the 1.1, 1.01, 1.001, these are called right hand side neighbor limits. So
Okay.
with this we can conclude that the function value at x is equal to 1 maybe 2, maybe 2, okay, but it is not exactly correct, maybe 2. So this is the concept of limits, and limits, the entire concept of limits is depending upon the approximation. So the approximate value of the function at x is equal to 1 maybe 2, okay, but every time we cannot, yeah, but every time we cannot find the values using this kind of methods, because every time we cannot draw the number line, every time we cannot find the value at each and every point, so we cannot find the value at each 1.1, we cannot find the value of 1.01, like that, so it's not going to possible. So we have certain
Yeah.
methods, yeah, we have certain methods when we have the value of the function is indeterminate, so then we'll approach that kind of things, okay. One second. Yeah, now, so coming to the exercise problems which were given by you.
Yeah.
So I think we can
This
directly,
one we can just substitute, right?
yeah, we can just substitute. So limit 4
Plus
into
12.
3, it is 12. It is directly, it is independent of function, so always is 3. And even this 1 square minus 1 by 2 into 1, so 0 by 2 is 0. And even this is 2 by 3 minus 3, which is 2 by 0, undefined. So no need to do rationalization for this thing, because if it is indeterminate only, then we can do a rationalization or something
Yeah.
else.
My teacher doesn't want me to put just put DNA. She wants me to put DNA
Yeah,
and positive India or something. She doesn't want just DNA.
okay.
Yeah, that's all.
Yeah. Now coming to this method,
Yeah, this one I think we had to like.
yeah, before directly substituting the value, before directly writing the answer, so let us check whether it is actually giving indeterminate form or not. So roughly, so if you substitute 2 directly, it will become 2 square plus 3 into 2 minus 10 by 2 minus 2. So in denominator we got 0, and in numerator 4 plus 6 10, 10 minus 10 0. So 0 by 0 again, it is indeterminate. So for this we have to do something, and if you observe closely, the numerator is a quadratic equation which we can do factorization and we can split it into linear equation. So let me do the fact. Yeah, exactly. So x square plus 3x minus 10 can be written as, so we can write the factors as 2 and 5. So x square minus 2x plus 5x minus 10. So it would be x into x minus 2 plus 5 into x minus 2, x minus 2 into x plus 5 by x minus 2. So limit x tends to 2, so it will become, both gets cancelled, then we can directly find the value, so by directly substituting. So limit x tends to 2, x plus 5 means we can directly substitute 2 plus 5 and the value is 7.
Yeah.
And even the same is the case with this thing. So x cube minus 27 by x minus 3. So x cube minus 27 can be written as 3 cube by x minus 3. So again, it is of the form a cube minus b cube. So we know the formula for a cube minus b cube is a minus b times a square plus ab plus b square. So it would become x minus 3 into x square plus 3x plus 3 square by x minus 3. So we can directly cancel x minus 3 here. So limit x tends to 3, x square plus 3x plus 3 square is 3 square plus 3 into 3 plus 3 square. So 9 plus 9 plus 9 is 27. So yeah, so that is the main thing here. If we are directly substituting the values like 3 cube 27 minus 27, we'll get, yeah.
It's automatic.
So then we should not do this method, and we have to do by following certain methods. So here we have the chance of doing factorization. So then I use the factorization concept for numerator, then I split into two terms. So then the denominator and numerator gets cancelled, then we can directly find the value. Okay. Yeah. Now here is the case we cannot do factorization, because root 1 minus x minus 2, it is not a second degree equation, it is neither a first degree equation, so it is under square root, so we cannot find directly by doing factorization or something like that. So first let me substitute the value directly, and let me check if there is giving any indeterminate form or a finite value. So let me check by substituting the value of minus 3 in the function. So it will become 1 minus of minus 3 minus 2 by minus 3 plus 3. So root 4 value is 2. 2 minus 2 is 0. So 0 by 0 is 0. I mean 0 by 0 is indeterminate form. So for this we have to do certain different methods without directly substituting that value. Now here we have some, I can say in the entire concept of limits we are using more oftenly these methods. I'll write here. Number one is factorizing, or taking some term as common. And number two is by doing rationalization. And number three is directly with the help of formulas. If the question is of trigonometry, more or less involved in trigonometry, inverse trigonometry, all these things we can directly use a formula, exponentials.
Yeah.
Right. So for this thing, we can blindly remember that if the question is containing any square roots or cube roots, we can directly go with the help of rationalization. So let me write the answer here. So root 1 minus x minus 2 by x plus 3. So here the numerator contains root of 1 minus x minus 2. So with the help of rationalization, I need to multiply the same x plus 2 by root 1 minus x plus 2. So I can write the numerator as a minus b in the a plus b form. So it would be a square minus b square. So it would be 1 minus x whole square minus 2 square divided by x plus 3 into root 1 minus x plus 2. So here square and root gets cancelled, so that will become 1 minus x minus 2 square is 4 by x plus 3 into root 1 minus x plus 2. So that would become 1 minus 4 minus 3. So minus x minus 3 divided by x plus 3 times root 1 minus x plus 2. So I can take minus as common here in the numerator. That will become minus of x minus x plus 3 by x plus 3 into root of 1 minus x plus 2. Now I can cancel out these x plus 3 terms, and then directly I will replace the value of x is equal to minus 3 tends to minus 3. So that would become minus 1 by 1 minus of minus 3 is 1 plus 3 4, and root 4 value is 2. 2 plus 2, so that is minus 1 by 4. Okay.
Okay. Yeah.
Yeah. Now B question. No, it is a more or like a similar type of question as the previous one. So before
Both sides
yeah,
by root x plus 3 plus root 3.
yeah. And the method which I'm telling now, to do rationalization, we can do even the value is determined. I mean, we can, it is finite also we can do. So it is not compulsory that we should do only these methods only if the value is indefinite or indeterminate. So there is rationalization and taking the term as common. All these methods we can do for normal problems also, but it will be time waste. Okay, so
You
we,
need more time, right?
yeah, more time. So just remember that. Okay, now here we'll check the
Yeah.
value whether it is giving us an indeterminate form or a determinate form. Let me check by directly substituting the value as 0 in place of x. So it will be root of 0 plus 3 minus root 3 by 0, and it is root 3 minus root 3, 0 by 0. Yes, it is indeterminate form, so we can do rationalization. So root of x plus 3 minus root 3 by x times, so I'll just rationalize the numerator, so it will become root of x plus 3 plus root 3 divided by root of x plus 3 plus root 3. So directly the numerator is of the form a minus b times a plus b. We can write it as a square minus b square. It would become x plus 3 whole square minus root 3 whole square by root x plus 3 plus root 3. So square and roots gets cancelled, square and roots gets cancelled. That would become x plus 3 minus 3 by root x plus 3 plus root 3. So 3 and 3 gets cancelled. The value is x by root of x plus 3 plus 3. And finally, we need to substitute the value of yeah, we got denominator, we forgot the denominator, right? Here we have yeah, so times denominator is there, x, right? Here it is x, right? We have forgot it. Yeah,
How do you know? Yeah.
yeah. So this x and this x gets cancelled, so now directly we can substitute the value of 0 in place of x. So that become 1 plus root 0 plus 3 is 3, and plus 3, so it become 1 by 2 root 3. Yeah. Now solving this
Mainly,
step
I'm having some questions on like
trigonometry.
if you see like I sent you like one of them it says 1.10, 1.13, which is that like continuity.
Let me check.
I'm having mainly questions on that. It's like fourth one is
Yeah, oh, okay, one more assignment we have sent it right. 1 second.
yeah that one 1.10.
Yeah, continuity, right.
And then IVT intermediate
Value theorem, mean value theorem. Yeah.
yeah I think she didn't go much in depth but I just like some questions I'm kind of unsure
Okay.
about so
If you don't mind, let me. I mean, I'll solve it and send you, and we'll connect in half an hour or other time, like morning, early morning, because
yeah
I'll solve it now itself and I'll send it the answers. But I'll explain you in the morning because here some work is there for
if
me.
tomorrow has school can we do like
Early morning,
okay yeah we'll figure it out
or else after some 30-40 minutes I'll be free because in 30 in meanwhile I'm having some uh, same weekend class. I'm taking
oh
other class for
yeah
physics for students in London, so he's
yeah
also, yeah, only once in a week I'll take for him. So uh, give me some 30-35 minutes. I'll be get back to
yeah
you.
yeah sure
Yeah,
you can take your time
yeah, yeah, thank you. I'll connect in 30 minutes.
yeah
So, as we have discussed the introduction of topic limits in the previous video and the previous class, so we are straight away moving to some other questions regarding the limits in trigonometry functions. And before going to this topic, let me introduce you some basic formulas which we have to remember so that the problem solving part will be easier. So there are certain formulas which are very important and which are mandatory to learn before solving this limits problem. So let me show you that formulas. Yeah, coming to the starting point, we know yeah where the topic of limits comes from, indeterminate form. So what are different kinds of indeterminate forms? 0 by 0, infinity by infinity, infinity minus infinity, 1 power infinity, 0 power 0, infinity power 0, 0 into infinity. All these things are indeterminate forms. And as I told you, what is left hand limit and right hand limit, the neighborhood of left hand limit, neighborhood of right hand limit, all these things we have discussed in the previous class. And there are some basic formulas in limits. Limit x power n minus a power n by x minus a is given by n into a power n minus 1. The same formula can be written as limit x tends to a x power m minus a power m by x power n minus a power n is equal to m by n a power m minus n. So even this formula is also there. And limit x tends to 0, 1 plus x whole power n minus 1 by x is n. And these are very important formulas regarding trigonometry. Limit x tends to 0, sin x by x is equal to 1, and limit x tends to 0, x by sin x is also equal to 1. And as far as limits concerned, we have same type of formulas for both sine and tan. So limit x tends to 0, tan x by x is 1, and limit x tends to 0, x by tan x is to 1. Good morning, welcome back to Tutor Lokesh channel. So in this video, we are going to continue the topic which we are discussing in the previous class. So that is limits, and limits is a part of calculus, which will be major subject in +1, +2, and even in engineering mathematics. So we know all these formulas, and we have got the introduction about limits in the previous class. So let me solve straight away with the problems, and before going to the problems, let me revise the formulas once again. We got certain important formulas for limits. If you see here, uh, as far as algebraic limits is concerned, and for trigonometric limits, we have different formulas, and you must remember these formulas before solving any problem. But not at all formulas, but there are some very important formulas which will make you to solve the problem very easy, and you can get the answer in an easier way within a limited time. So that's it, that's all I can say. So these formulas will save you a lot of time if you're solving for any competitive examinations, right? So regarding algebraic formulas, we have got the two important formulas. One is this and one is this thing. So limit x tends to a x power n minus a power n by x minus a is given by n into a power n minus 1. So this is a formula, and I will derive the formula. No, what you call, you don't need to figure out something like we are by heading match. Don't need to do things like that. I will derive the formula because we got some important concept. But before deriving this all these things, let me introduce you once again. So you must remember this formula so that it will be easy for you while solving the problems. And the same type of formula is there, same type of expression. Limit x tends to a x power m minus a power n by x minus a, it is given by m by n into a power m minus n. And limit x tends to 0 sin x by x is 1, and limit x tends to 0 x by sin x is also 1, even reciprocal of n is 1. And in limits particularly, the formulas which we are using for sin theta will be same as for tan theta. So that means limit x tends to 0 sin x by x is 1, and limit x tends to 0 x by sin x is also 1, and limit x tends to 0 tan x by x is 1, and limit x tends to 0 tan x by tan x is also 1, and limit x tends to 0 sin inverse of x by x is 1, limit x tends to 0 x by sin inverse also x 1, limit x tends to 0 tan inverse of x by x 1, and limit x tends to 0 x by tan inverse of x 1. So we got all the formulas regarding sine and tan. So you don't need to remember differently because all sine formulas will be same for tan formulas. So let me explain you this fifth concept. Limit x tends to 0 sin x power 0 by x, and we know that how to convert the degrees into radian. We know that 1 degree is equal to pi by 180 radian. So sin x degree will be sin x times pi by 180 by x. So it is of the form sin ax by x. And sin x by x is given by a. So in the same way, x degrees can be written as sin of x into pi by 180 by x. So it is of the form sin ax by x. So the answer is a, pi by 180. That's it. And there are certain important exceptional formulas which are not like unlike the same formulas. Most of the limit formulas are defined for x tends to 0, but there are some formulas where limit goes beyond infinity or tends to infinity. So you should remember that formulas, and whenever limit x tends to infinity, sin x by x is 0. So see, the whole concept is very simple. Limit x tends to 0, sin x by x is 1, and limit x tends to infinity, sin x by x is 0. I'll explain how this formula actually was derived. If x tends to infinity, what is 1 by x tends to? So definitely we know that 1 by undefined is 0. So if x tends to infinity, or if x is equal to infinity, 1 by x will be equal to 0. So I can write this as limit 1 by x tends to 0 sin So I can write sin x by x as yeah. Yeah, see, very simple. Yeah, I got the point. So limit extends to infinity, sin x by x is 0, because we know that sine is a definite function. I mean, sine, the if you look at the range of sine, if you look at the domain of sine and domain and range of sine, the domain of sine is r. So we can put any value in the domain of sine. So sine x accepts any value. Like it sine is 0 for 0, sine is defined for 1, sine is defined for pi by 2, sine is defined for pi by 3, pi what not. So sine will never become undefined if you put any real value. So that means sine of infinity will definitely be in the range of minus 1 to 1, right? Because we know that the range of sine is minus 1 to 1. So even if you put sine undefined, so undefined will be some value. So even if you put that value, the returning value will be a definite value, and definite value by undefined, anything by undefined is always 0. That's it. Okay. And we got these two important formulas, and even this, so we need to remember. We should not forget this thing, important formulas. I'll show you how this came. Even this log 1 plus x by x is 1, whereas log a 1 plus x by x is log a to the base c. Yeah, yeah. Now even these are very important, which will come as 1 pod infinity. So straight away moving to problems, limit x tends to 90, sine 2x is. So directly we can substitute the value. So we should only look whether the value is becoming indeterminate or not. Otherwise we can directly proceed with the value. So sine pi, and we know that sine pi is actually 0, because sine 0 is 0, sine 180 is 0. So the answer is 0. And regarding this question, limit x tends to 0, sine square x. So limit x tends to 0, sine square x by x. Since I know the formula, limit x tends to 0, sine x by x is 1. Limit x tends to 0, sine x by x is 1. So I can use this formula to solve this problem like this. So limit x tends to 0, sine square x by x. So I can write sine square x as sine x times sine x by x. So this will become 1, because as per the formula, limit x tends to 0, sine x by x is 1. So 1 into limit x tends to 0, sine x. And we know the value of sine at 0 is sine 0 is 0. So 1 times 0 is 0. So limit x tends to pi by 2, cos by cot. So let me simplify this before substituting directly. So cos x by cot x can be written as cos x by sin x. So which will in turn, it will become cos x into sin x by cos x. So now both cos x cancel. So limit x tends to pi by 2, sin x is sin 90, and that is equal to 1. And again, limit x tends to 0, tan x by x or sin x by x is 1 as per the formula. So I'll write it here. So limit x tends to 0, sin x by x, which will be same as limit x tends to 0 tan x by x, which is equal to 1. So the answer for is straight away 1. And limit x tends to 0 sine 5x by x, so it will become limit x tends to 0. We know that formula, limit x tends to 0 sine ax by x is a, so it will be 5 as per the formula. Now regarding coming to this equation, this is very important equation. We can solve it by 2 or 3 different ways. So let me select my own approach. So limit x tends to 0 sin x times 1 minus cos x by x square. So I'll distribute this x square to the here, and 2 will be left here, so I'll write 1 by 2 here. So I can write like this, right? I don't think anyone has problem in writing like this. So 1 by 2 into sin x into 1 minus cos x by x square, because I have the formula. Limit x tends to 0 1 minus cos x by x square is 1 by 2. We have the formula. So don't confuse with the problem, it is formula, okay? So if I write any formulas, I'll definitely write it in a box. So it is not a part of problem, but it's a formula. So limit x tends to 0 1 minus cos x by x square is 1 by 2. So I can write the answer as 1 by 2 into limit x tends to 0 sin x into 1 minus cos x by x square, limit x tends to 0 is 1 by 2. So the answer is 1 by 2 into 1 by 2, 1 by 4 into sine 0. And we know the value of sine 0 is 0. So 1 by 4 times 0 is 0. So it is 0. So like this, limit x tends to 0, 3 sine 4x by x. And it will become 3 into limit x tends to 0 sine 4x by x. So the value is 4, because we know that limit x tends to 0 sine ax by x is a. So in the same way, limit x tends to 0 sine 4x by x is 4. So it will become 3 times 4. So that is equal to 12. And see, you must remember the formula when you see this question immediately, because it is of the form sine ax by x. So you must remember the formula. Sine ax by x is a. So it will become 3 times 4, 12. So limit x tends to pi x secant x. So that will become, I think we can directly substitute the value, because no way it will be going to be in indeterminate form. Secant pi, cos 180 is minus 1. So secant pi is also minus 1. Reciprocal of minus 1 is also minus 1. So I can directly substitute here. So pi times secant pi. So it will become pi times secant pi is minus 1. So the answer is minus pi. And coming to 9th question, limit x tends to 1 by 2 x square tan pi by x. You need to have some kind of thinking before solving this question. I can say, if we substitute the value of x in terms of in place of 1 by 2, it will become tan pi by 2, which will become undefined. Though undefined is accepted in certain cases, yeah, what you said is exactly correct. We may think that we can write in the form of tan ax by x, because some people think that, see, let me explain you very clearly. The answer for this question is undefined, but let me also tell you how we will be cheated, or how we will be confusing whether solving this type of problems. Let me explain you here. I may think that, so I can solve this problem x square into tan pi x by, I am multiplying with x and dividing with x. So dividing and multiplying with x. So tan pi x by x, you can think that we know that limit x tends to 0, tan ax by x is a. But if it has to be happened, limit has to be tending to 0, but here it is not that case, so we cannot directly use this formula. So what I have to do, we have to straight away substitute the formula. Okay, so that's a better choice. So it will become 1 by 2 whole square tan pi by 2, and we know that it is not indeterminate, the value is undefined. We know the see, when we have to use certain different forms, when the value is indeterminate, 0 by 0, infinity minus infinity, 1 power infinity, 0 into infinity, infinity times 0, like that. So it will become 1 by 4 times undefined, so the value is undefined. So regarding this question, limit extends to pi for 1 minus tan x by sin x minus cos x. So if we substitute directly, let me check whether we are getting any indeterminate form or not. So before solving each and every problem, we have to check whether the limit is giving indeterminate form or not. If it is giving a definite value, we can straight away proceed with the answer. If it is giving indeterminate form, we must stop there and we must look out for some methods, like can we do factorization, can we do rationalization, can we substitute any formula, like that. So we must look for indeterminate form. So if it is indeterminate, then we should not proceed. So 1 minus tan 45 is 1 by sin 45, 1 by root 2 minus 1 by root 3. Yes, it is giving indeterminate form, so we should not directly substitute. So what I have to do is I have to convert this given question. Without any second thought, I can directly convert this tan in terms of sin and cos, so that would be very easy for me. So it will become 1 minus sin by cos by sin x minus cos x. So if I do the LCM of 1 minus sin by cos, it will become cos into 1 cos minus sin by cos into sin minus cos. So both gets cancelled, but there is one negative symbol, difference of one negative symbol. So I can write it as a minus of sin x minus cos x by cos x into sin x minus cos x. So both gets cancelled, that will become minus 1 by cos x, will become minus secant x. So now if you substitute the value of secant pi by 4, yeah, cos 45 is 1 by root 2, secant 45 will be root 2, so it will become minus root 2. So that's the answer. Okay. Now coming to limit extends to pi, so cosecant pi, we know that cosecant pi is undefined because the value of sin pi is 0, so whereas cosecant pi is undefined. And regarding the numerator, so if we substitute directly root pi by undefined, so definite value by undefined is always 0, so that's it. Or we can straight away use that thing. Limit extends to 3 plus secant pi by 6x. So yeah, here we have to be a little careful because they are not asking you to put the value of 3, they are asking you the right hand neighbor side or the right hand limit of 3. If you substitute 3 here, so it will become 3 pi by 6, so which will become pi by 2, secant pi by 2, cos pi by 2 is 0, and secant pi by 2 is undefined, so which will be a like it's not, yeah, it is undefined, so we have to look whether we can get any value if we substitute anything like this or I don't think we can get any value, because undefined is completely acceptable. It is not indeterminate, it is undefined, so it is completely acceptable, so we can directly substitute the value. So limit extends to plus or minus undefined, or limit extends to plus or minus infinity minus 10x by 10x plus 2 by x square plus 5. So we can substitute the value of infinity here, so it will become 10 into infinity, infinity by infinity square, it will be infinity. So infinity by infinity, we are getting indeterminate form here. So there will be some magic here. So as I told you, we can either factorize, or we can do rationalization, or we can use substitution formula. So regarding this, if any limits tends to infinity, and if we are getting infinity by infinity form, so we have this magic called taking a highest degree term as common. So that will become, in numerator the highest degree is x, so I'll take x common. So that will become minus 10 plus 2 by x, whereas in denominator x square is highest power, so I'll take x square as common, so it will become 1 plus 5 by x square. So now I'll run limit. So 1x and when x square gets cancelled, that will become 1 by x into minus 10 plus 2 by x divided by 1 plus 5 by x square. So if I substitute the value of infinity here and here, so it will become 1 by infinity is 0. So 0 times minus 10 plus 0 by 1 plus 0, so it will become 0. So the answer is 0, because anything by undefined is 0, right? So it will become 0, minus 10 plus 0 is minus 10, by 1 plus 0 is 1, into 0, because we got this thing in front of this expression. So 1 by undefined is 0, so 0 times anything is 0. Similarly, a limit x tends to plus or minus undefined 2x square plus 3x minus 5. So if I take out x square as common, as I told you, we have to take out highest degree term as common in the numerator and denominator. So if I take x square as common, it will become 2 plus 3 by x minus 5 by x square divided by x square times 1 minus 4 by x square. So I can cancel x square terms on both sides, so it will become 2 plus 3 by undefined is 0, minus 5 by undefined is 0, 1 minus 4 by undefined is 0, so it will become 2 by 1, which is equal to 2. So same kind of thing. So if you substitute directly the infinity value, we'll get the indeterminate form in the form of infinity by infinity. So let us take the highest degree terms in numerator and denominator as common, then we can solve these things. So if I take x square as common, so 4 plus 1 by x minus 7 by x square divided by, if I take x square as common, it will become 1 minus 5 by x minus 3 by x square. So x square cancel. So if I substitute the value, 4 plus 1 minus it is 0, 0 by 1 minus anything by undefined is 0, 0. So the answer is 4. So we have a shortcut for the JE kind of examinations, and I'll explain you how to solve these questions for JE. So limit x tends to infinity x square by root of x square plus 1. So it will become If I substitute infinity here, it will become infinity, and here also it will become infinity. So what I have to do is I'll not disturb the numerator here. In denominator, I'll take the highest degree as common. So if I take x square as common, it will become 1 plus 1 by x square. So x square by, so root of x square is x times root of 1 plus 1 by x square. So 1x and x square is cancelled. So x by root 1 plus 1 by x square, whereas x tends to infinity. Now it will become infinity by root 1 plus 1 by infinity. So it will become 0. So infinity by 1 is undefined. So the value of this is undefined. That's it. Even this also. So I'll take x as common. In denominator, I'll take x square as common. So that will become x times 5 plus 3 by x divided by root of x square will become x times 1 plus 7 by x square. So x gets cancelled. Now we substitute the value of undefined. So it will become 5 plus anything by undefined is 0 by root 1 plus 0. So it will become 5. So in denominator in this question, I'll take x power 4 as common. So 4 plus 1 by x power 4, and x power 4 will become x square if it comes out of the root. So that will become 4x square by x square times 4 plus 1 by x power 4. So both gets cancelled. So 4 by 4 plus, if I substitute the value of undefined here, so 1 by undefinite or 1 by infinite is 0. So 4 by 4 is 1. So yes, like this we can solve the questions which are being tend to indeterminate form when we directly substitute the limit. So we have certain methods like doing rationalization, doing taking out something as common, or doing factorization like this. So we have to follow that methods, and then we can solve the problems. Thank you.